Example 3 is a word problem. In this problem, we have a factory that produces 3 different types of products: widgets, sprockets, and grommets. To produce 1 unit of any of these 3 products requires some number of hours in the machine shop, some number of assembly line hours, and some number of hours to paint. The table here describes the number of hours of each type required to produce 1 widget, sprocket, or grommet. In addition, the problem states that the factory has a certain number of hours available of each type. There are, in a given day, it has 202 machine shop hours available, 84 assembly line hours available, and 76 painting hours available. So the factory wants to figure out how many widgets, sprockets, and grommets to produce so as to use all of the hours available to them. Okay, so there are 2 parts to this problem, Part A and Part B. Part A simply asks us to set up a system that models the problem described. And we're asked to clearly indicate what any of our variables represent. So, in Part A, I'm going to start by labeling my variables. Let x equal the number of widgets produced, y is going to be the number of sprockets produced, and z is the number of grommets. If you prefer to use something a little more descriptive like w, s, and g as your variables, you're absolutely welcome to. I tend to use x, y, and z just to give us some consistent variables that we're going to use in pretty much all the problems. Okay, but now that I have my variables, I need to start setting up equations. I know that I want to use up all of the machine shop hours available to me. So the total number of machine shop hours used would look like this. Each widget produced requires 3 machine shop hours. So 3 times x is going to give me the total number of machine shop hours used just to produce widgets. Each sprocket requires 5 machine shop hours, so 5 times y is the total number of machine shop hours required for sprockets. Similarly, grommets require 3.25 machine shop hours to produce, so 3.25z is the total number of machine shop hours required for grommets. If I add those 3 quantities together, I want that to equal 202, which is the total number of machine shop hours the factory has available. I can proceed in a similar way for assembly line hours to get 1.25x plus 2.25y plus 1 times z. And that should equal 84. And then for painting hours, I have 1.5x plus 1.25y plus z equals 76. Okay, so now that I have the system set up, Part B asks us to solve it. We still do not know how to solve these by hand, and in fact, any word problem I give you in this class, you will be allowed to use the RREF function in the calculator to solve the word problem. There will be a few problems I ask you to do by hand, but not any of the word problems. I will ask you to set up the system, though, just like we did here in Part A. So to solve this in Part B, I need to put the system into an augmented matrix, which gives me 3, 1.25, 1.5. That's the first column. The second column is going to be 5, 2.25, 1.25. And then the last column is 3.25, 1, 1. And, well, okay, the actual last column is 202, 84, and then 76. So then I'm going to use RREF, the RREF function in the calculator, to put this in reduced row echelon form, which is going to look like this. Okay, so my answer here, I get x equals 32, y equals 16, and z equals 8. However, these variables, x, y, and z, are things that I invented for this problem. The answer should be, since this is a word problem, the answer should be more descriptive than just x equals 32, y equals 16, and z equals 8. I should actually explain what these numbers mean. So to do that, I'm going to write, as my answer, 32 widgets, 16 sprockets, and 8 grommets. This is how many units of each product the company needs to produce in order to use up all of the resources available to it in a given day.